We have one more part left to this question about cassette sales, and that's this. Predict the cassette sales in 2002. Notice that this is what we call an extrapolation because our data doesn't go beyond 7 years past 1994. I'm trying to go back beyond 2001. So 2002 is outside of our data set and therefore an extrapolation. So if we just do this without worrying too much, this would be vars y vars function y1, and I'm going to do it like this. I'm going to say 2002 minus 1994. Remember, it's an elapsed time model, and we started it in 1994. And so there's our answer, and this is kind of alarming. It says negative 7.8677, so let's say negative 7.868. Okay, that's a problem because it's negative. So we can't have negative sales, right? And what this is doing basically is we started off, somewhere up here, and then we have these other data points. But by 2002, we're actually underneath. Our linear model is predicting that we will be in negative sales. So our linear model is really not any good anymore. So this is an example of why extrapolation is dangerous, because it can kind of give you unusable or absurd values, and so this is one of them. So if you do a scatter plot of this data, you'll notice that it actually, maybe a linear fit is not really the best model to use. It actually looks something a little bit more like that, and so you might be inclined to use a model. If we could do a regression that gave us a model like this, that might be better, and you can, and we will talk about it in the next sections. Okay, but for the moment we have a linear model, and it looks like it's no good after 2001 at some point. Okay, another example. This is actually an example from your textbook. And we've got a fairly large data set here, at least bigger than the other ones we've seen. And what is this? What are the variables here? So we've got the scatter plot of chirp rates of cricket chirp rates, so chirps per second, versus temperature. Okay, so this is temp down here, and this is your chirp rate. Okay. So I believe we looked at this already, and back in section 3.3, and we had a black thread method model for this. But what I want to do now is compare that to the linear regression model, just to kind of remind you that you can have two different models with different SSEs and so forth, and how to work with both of them. Also, we might need to know how many data points we have here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So n is 15 here. And the black thread method, remember what that is we eyeball a line that goes through about half above and half below the data. So here I've got a picture of this. So there's my black thread method line. And then I actually did a proper linear regression, and I got this line. Okay. The black thread model that we got by eyeballing the line is right here. And so we could take that model, we could type it in as Y1, we could compute the SSE, compute the average error, and here they are. And then if we went back and then did the regression after we typed in the data, and save that as a function, then we would get this model, and you see we have another SSE, another average error, and a correlation coefficient. And notice that, as expected, this SSE for the linear regression is smaller than this one. Why? Well, because it's the linear regression, and it is by definition the best fitting line. So it has to be small, at least this number or smaller, okay, for any other supposed model for this, okay. In terms of correlation for our linear regression model, we got 0.825, and with 15 data points, if you go to your critical value, you will see that that's 0.514. So certainly our correlation coefficient exceeds our critical value, and therefore we can be 95% confident in correlation and in positive correlation. It's positive because the correlation coefficient R is already positive. So it's an increasing linear correlation, which basically means as we increase the temperature, the chirp rate increases. Now that's only going to be true up to a point, because if you get too hot, I don't think the crickets will be chirping anymore. You'll fry them, right? And so our model won't be valid anymore. But up to a point, this is a increasing linear model. Okay. All right, and that about wraps up section 3.4. So from here, we will move into, we're actually going to jump into chapter 5. So we're skipping chapter 4 for the moment. We're going to jump into chapter 5, and then we'll come back and we'll do chapter 4 in unit 3. But chapter 5 is going to be the bulk of unit 2. So that is what is to come.